Great, so we're just getting started here. This is the e-NABLE Education monthly meeting. We bring together students and teachers from around the world that can join us and share some of the exciting work that they're doing. I'm sure we'll have people that will pop in and out during the call today, but while we're waiting for the last few minutes, I can quickly introduce Jana. Is that right?
Yes.
Jana. Jana is with us from Spain, and she's been working on a really wonderful design. It's a bionic design that uses muscle contractions and research of how muscles work to work. So maybe I can pass it along to you, Jana, and you can share with us a little bit more about your project. And again, let's maybe wait a few more minutes until people arrive.
Sure. Well, I'm gonna share my screen. Okay, I can. Well,
great.
It doesn't allow me to.
Oh, let me fix that. Okay, you should be able to now.
Yes. Okay, so you want me to start?
Yeah, that'd be great.
Okay, so during the last 8 months, I've been working in a project called In Handy, which is a prototype of a bionic hand. And well, today basically I'm gonna be talking a little bit about the process. So first I'll show a little bit the design, how I planned it, and then show some of the electronic components I used and the process of building the 3 programs I made. And I'll then explain the final product. You'll be able to see it, and also the budget, which I think is quite important. And finally, some improvements because it's far from finished. So this is the design. All these holes are for servo motors, which allow the movements of the fingers, so the joint movements. And I use the program OnShape for the design, which is open source, and G2Box 64 to prepare all the pieces before printing. There's nothing much else to say. The fingers just flex and extend, and then there's this special movement for the thumb, which also flexes and extends. And this is the compartment of the Raspberry Pi, so the CPU. So I basically decided to not use strings and just use more printed pieces for the joint mechanisms. And I used the Resign printer because I believe since all the pieces are quite small, it just makes it more accurate as well as precise. And finally, I emptied all the pieces so that the weight diminishes and the resistance is still good, it works perfectly. And now the electronic components I used are the Raspberry Pi, then the Servo Motors to make the fingers move, and an EMG sensor with an ADC board. So an ADC board is an analog to digital converter. So I needed this because the sensor outputs an analog signal, but the Raspberry Pi just reads digital signals. So probably an improvement would be to change the Raspberry Pi to another board that reads directly the output of the sensor. And the assembly was quite easy. As I said, I used G2Box to prepare the design. Then I used M3 screws to put everything together. This was quite easy, like there's nothing special about this process. Then I used the protoboard to have all the electronic components before welding everything and having this final design. Also, into the programming, I made 3 different programs. The first 2 ones were more like tests that asked the user for input. So the first one asked for a signal. So if the hand has received the signal, and then the second one asks to flex or extend the fingers or the joints. And finally, I made the last one, which uses directly the EMG sensor. So this is the program that we will see here. So this is the hand. As you can see, the Raspberry Pi is quite big in compared to everything. Like all the measurements were made compared to the Raspberry Pi. This is a thumb piece. This is the ADC board, which is connected to the EMG sensor with all the 3 electrodes.
Wow.
Here I just put the name in handy because I could, I don't know.
How many parts do you have altogether in the design?
Uh, 21, I believe. I just counted them. I think it's 21.
Wow.
Not bad.
Okay. So you can see these 2 top electrodes are put on the sensor pollicis longus, which is a muscle that contracts when there's a movement of the thumb. So we will see the movements that cause this contraction in the last part. But right now, we'll see the movements that cause the contraction of this muscle, that is the flexor digitorum superficialis, which is contracted when there's a movement of the last 4 digits. Yes, so basically, as I said, when the thumb was flexed, there was a movement of the thumb piece. And when the other fingers were flexed, there was a movement of all the flexion of the other fingers. So this is the budget. In total, it was about $167, although I made it in euros. So this is approximately what it would be in dollars. And as you can see, most of the price was spent in the electronic components because both the Raspberry Pi and the EMG sensor are quite expensive. So since, as I said, the Raspberry Pi is not maybe the best it's probably not the best option for this project. If that could be changed into a more affordable option, so the price could diminish. And then
And you said if 89% of 167 is about $150, how much is the Raspberry Pi in and of itself?
Was about 60 euros, which is about, no, it doesn't surpass $65.
Okay.
But yeah, it was quite expensive. But since I knew I would be using it for other projects, I thought it was a good investment.
Yeah.
And then since all the pieces were emptied, so there wasn't resin inside, the price of the resin was quite good. It's very affordable. and the assembly materials are screws and everything that was needed to weld everything, which it's actually like it's quite affordable also, because there were a lot of these pieces. And some improvements would be one to cover the electronic components, because as I showed you right now, the Raspberry doesn't have anything and there are all the wires there. And since it's a prototype, that's okay, but that would need to be covered, to have a cover. And then another option is to make an electronics-free mechanism, but this would be to make a whole new project, but using the same design. Then to accommodate it ergonomically into a user, so change some part of the design also. And finally, add other motions, such adduction of the fingers or a gripping fabric, because the material is quite slippery. So to grip something, we would need to have more friction. And that's it. I believe you have the link to everything. So if you have any questions.
It's a great presentation, Jana. Thanks for sharing with us. I do have your presentation link that I shared on the hub. I mean, most of the stuff that I wrote down sort of was concerned about the budget, but you had a really great page on that. And I'll pass it to John.
Let me say hello, Jana. I'm so sorry I missed the very beginning. Since I'm the
That's
only
okay.
guy here, can I see your first few slides just to see what I missed?
You didn't miss much, I believe.
Can I see your first slide?
I've got the link. Let me put the link in the chat for you,
Okay.
John, and you can just check
Because
it
it
out.
looks like it's just a terrific design. And I have to say, I've never seen mechanical linkages done as well. I've never been able to figure it out myself, and the ones that I've seen have a great deal of complexity. So I'm just, hang on a second. Okay, so I didn't actually miss much, but I want to. So can you go to your second slide, or I can do it, but I'd like you to talk a little bit more about the mechanical linkage.
Sure. Well, so I don't know. Since I knew that I would be using Servo Motors because they are small, and well, I just thought it was the best option because they're very precise and you can make them move into the angle that you want. I thought that I just had to do like an elbow type of mechanic movement. So that's what I did. So as you can see,
is this one piece, or is this actually a moving part here also?
No, it's just one piece, so it doesn't move. It just it just goes down, so that it doesn't touch any of the other pieces. So it allows better motion, so better flexion.
Very interesting. And so here we are, where we've got a lot of those. And the servos, you have one servo for each finger. And then you've got all of the electronics here.
Yeah, so under this piece, there are all the wires. So I just put this piece to have the wires, and then this rectangle, and have on top the Raspberry Pi, just so they are not touching each other.
And the whole design is 3D printed, correct?
Yeah, everything is 3D
All
printed.
21 pieces.
And no wires, no strings. So
And
the
then hardware,
servos
I guess.
fit into that slot,
Yeah.
and servos rotate. And I can't quite picture the way the rotation of the servo
Okay.
connects to the linkage. Do you have the mechanism with you?
Yes, I actually, yeah. I do.
No, we're talking.
So I'll try not to do that. So let's look at it with the thumb. Like, I shouldn't have chosen to make it black because, as you can see, it's not.
It's okay. Let me just. There
I
we
can
go.
pin your
Okay,
screen.
good.
Hold
Let's-
on one moment. There.
Maybe with more light.
That's good.
So this is the servo motor, and there's
Mhm.
just the arm of the servo motor which goes this way, and then the linkage.
I see.
Now.
That's great. Let me just look at that for a second.
Yeah.
So the servo has a sort of an actuating arm.
That's right.
Yeah. All the servos came with these arms.
Got it. I got it now.
So
Okay.
I actually had to use the welding machine to make the hole bigger, just so that the screws would go through. But it was, other than that, it didn't have many issues.
So it's really beautiful work, Jana. Did you introduce yourself? Where are you? How did you come to do this?
Okay, well, there's quite a long story. So I'm from Catalonia, a part in Spain, and like 2 years ago or so, before COVID, I went to the US to to go abroad for a year during high school, and so yeah, I went to New York State, and I was introduced into the world of robotics. I had never done anything related to it, and I was introduced to it. So I started going to some competitions, and then the teacher told me asked me if I wanted to do something related to this, and we were given the opportunity to make a project, and I chose to make a hand. However, then COVID hit, so I had to go home. And during the last 2 years here in Spain, we were asked to make a project. And I thought that I would continue this. So I did, and I ended up with this.
Wow.
And this was first robotics? Was your robotics competition with the first robotics program?
What do you mean? Like, it was my first year doing robotics, yeah.
In
You said there was a
in New
competition.
York State.
Yeah.
What?
Where in
Sorry.
New York State? In New York City?
Oh yeah, I was in Mexico, New York, so
Mexico, New York.
Oswego
That's not so
County.
far.
I actually met someone related to e-NABLE. Someone came to the high school, and I talked with them about this, but then I had to go home. So when I made this project, I just thought that I had to bring it to you, so tell you about it.
Oh, absolutely. And you're in university now?
No, I'm in the last year of high school.
Last year of high school.
Yeah.
You are way ahead of the pack. This is really very, very serious work. And who is coaching you on this?
So my technology teacher and also my English teacher, because I made it in English, but it usually would be in Catalan, our first language. However, I didn't really ask them many help because I was just, when I was doing it, things just came together. Like, yeah, there were issues, but mostly I was able to solve them by myself.
Very, very impressive. So what happens next? Are you going to university next year?
Yes, I'm planning on studying biomedical engineering and
Where?
in UPC, no, UPF. It's a university here in Catalonia. And then, I don't know, whatever it brings me.
That's okay. That's okay. So it does occur to me that the electronics don't have to be in the hand. You could make the hand simpler if the electronics were out here, say. And I assume there's a battery presumed, so that also could go here.
Mm-hmm.
But it's really interesting because you've done several things very, very well. One is the mechanical linkages. To me, that's really hard, and it looks like you've got a really good solution. Two, you have what looks like simple circuitry. You are using a Raspberry Pi, but it looks like you've done it in a nice, straightforward fashion. So you had to program it. And then let's talk a little bit about the programming. Did I understand that your program? Well, talk to us a little bit about the reliability of the sensors and the Raspberry Pi and how you get them calibrated properly.
Okay, so the sensor, it just what it does, it's basically like a potentiometer. I don't know if I say that right, but it basically gives voltage value. So whenever there's a contraction, the electrodes get it, and so it lets through more voltage. So that's why I think it's quite reliable, because it's just a matter of the electricity that goes through.
And do you get a lot of noise, or do they already do the filtering for you?
You can graduate it. So there's a gain part, so everyone can customize it. So if I want to make a lot of strength to make the movements, I can do so. But if I don't want to make strength, I can also choose not to.
And who makes the sensor component?
Bioware. I don't know if I pronounced it right.
Bioware, I've heard of that.
Yeah.
Okay. And when so I saw in your demo, you have it on your own arm and it's responding. Does it stay tuned, or do you have to keep on readjusting it?
No, it stays. It actually works well. I don't have to readjust it.
Fantastic.
And how long does it take
so,
to adjust to your arm? So when you first put the sensors on your arm, there's some calibration. I imagine everybody's arm is a little different, where the muscles are, and sort of how to collect information from the readings.
Yeah, so honestly, since I know where the muscles are, like when I put it in my arm, I know in the first video, I don't know if you can see it, but I'm basically making the movements, and when you make it now here, I can palpate. I can, like, I notice it, so I would then just put them there. So it would be just like making the movements that I need to do, feel the muscle moving, and then just put the electrode there, and then snapping the other piece, because it's like a button. Like, this is a sensor, and the electrode is just like a button. I just clip it there.
And John,
go ahead, Ben.
I was just going to ask about how sensitive they are, the sensors that you're working with. I mean, do you notice that you have to make sure that they stay in the exact same position. I mean, in terms of, you know, using the device, how are you keeping the sensors on the arm, just with tape or?
No, so it's the electrodes. They're just like
Suction.
They have adhesive
Yeah.
on them, I think.
Okay.
it's just like no, it's stuff like glue. It's not glue. I don't know how to say it in English, but yeah, it's really easy. It just stays there. Also, you can get them in a lot of hospitals. Like, for example, these electrodes, I went to a hospital, I asked for them and they gave them to me. Like, it was easy to get them.
I see. So you have medical electrodes, and then you have little sensor units. And then that goes to the Raspberry Pi.
Mm-hmm.
So what's touching the skin is a medical grade sensor of the sort that they use for EMGs and EKGs and
No, it's touching the skin. It's the electrode. So it's really like nothing. It's just like it's a gel. So it doesn't really feel like anything. It's like it's just sticky, so it stays.
Have we connected you with Vivek and the bionics group at e-NABLE?
I mentioned that meeting on Friday, or is it Friday? Yes. And that's something that you still can join. Yes, Jana?
Yeah, I can.
That's great.
Great.
So
we'll have this video that we can share with them as well.
That's right. Vivek may ask you to give the same presentation, which will be great. But then you should send Vivek this video so he knows what the story is, because it's a terrific story, Jana.
Yeah, that's the plan.
Impressive work.
We'll have the presentation published as of today, so Vivek's got all week to check it out, and then they can ask you some specific questions and share the work that they're doing. Alexander is a recent robotics college graduate in Romania, who's going to be leading a presentation during Friday's meeting, just talking about recent research and stuff. So it could be, I think, a pretty exciting conversation for you as well.
Okay, yeah, it sounds good.
So
great. Well, John's thinking. I've got a couple quick questions for you, John. This meeting is aimed at education. This is our monthly education meeting. So how has it worked for you in terms of school, especially transitioning from Mexico, New York back to Catalan? And where are you in Spain? You're in Barcelona, or?
Yeah. It's like the zone of Barcelona, but I'm in the northeast, so almost like 10 minutes from the sea, and like not even an hour from
Figueres, or?
Figueres, yes.
It's a great part of Spain.
Yeah.
So how has it worked for you in setting up this project in Figueres, and what did you have to do? I know a lot of students sometimes have some challenges working with teachers and making sure that things are set up with the school.
Yeah, so since this is like a mandatory project that we all must do, like all the high school students that are going to graduate, we all must do this because it counts like another subject. I had to do a project. However, what was challenging was convincing the teachers that I wanted to do this, because most of them were like, oh, well, how are you going to do this? Are you sure you will be able to do this? Actually, I also talked with a professor of a college here, and they told me that I wouldn't be able to do it, that I would have to change it, but I didn't. So But yeah, it was challenging. But then I talked with my technology teacher and I explained to him how it would be and basically everything. And he was like, okay, so then I'll be your tutor in all this project. And
Well, that kind of stubbornness and dedication must be something you learned in New York.
yes, definitely. Well, yeah.
I have advised a lot of university students who have wanted to do what you've done. And I've usually told them it's too complicated to take on. And some of them take it on anyway. And they prove me right. They aren't able to do it. So I know what an achievement this is. It's really terrific.
I mean, yes. I know that the project I have here is far from being used by anyone. Like, there are a lot of stuff that needs to be improved. But I think it's the first prototype, so I think it's quite good to be the first prototype.
I agree.
And
where are you on documentation? Could someone else say, "Oh, I want to work on this"?
It's like 100 pages of documentation. It's in the event, in the hub underneath the link to today's event. You can see a link to a 100-page document in Spanish and English, correct?
Fantastic.
Yeah, it is all in English, I believe.
Okay.
And Jana, this was resin printed, and you think it has to be resin printed to work reliably?
I haven't tried any other type of printer, so I really cannot say that it cannot be printed any other way. But I know that resin printers make more layers than other printers.
Mm-hmm.
Therefore, it makes the whole design more accurate. So the design that I made, that I have in the laptop, I know it will look a lot like the one that I will have after using a resin printer. However, if I did with another printer, like the typical filament printer, it wouldn't look as much alike because of the layers. But since I haven't tried it, I cannot say that it wouldn't work. I think it could be able to work, but do you
have any idea what a service would charge to print the parts using resin printers? Most of our people, of course, have FDM printers. I assume your resin printer is at your school or your university?
Yeah, well, I do robotics, and they have resin printers, so they lended it to me.
Right.
And you took it home.
But there are companies like Shapeways.
Yeah.
Have you sent them your design and said what would it cost to print?
No, because here, well, at least that I think here in Catalonia, or whatever, in the place I live, I don't think there's like anything like that. So it didn't even cross my mind.
They can take the files electronically and then they can ship them. That's something we might look into, because it sounds like you've produced what could be a good reference design for people to work with.
Yeah.
But the printing can be a challenge. On the other hand, there are some people who are going to get resin printers. So that's all great.
And again, this is a resin printer that your school had and you took home during this project. You sort of like checked it out from the school.
Yeah, kind of that. Like, I still have it. I need to bring it back soon.
And you set it up at home in your basement, in your bedroom?
Yeah, in the room that no one's using because resin is toxic. Right. So that's the issue, that when I had to wear gloves as well as a mask while handling the liquid resin. When it's solid, it's totally safe, but when it's liquid, it is toxic. So, but while it's working, like you can be in the same room while while pieces are printing. It's totally safe. But it just when, for example, when taking the pieces out or changing the resin or anything, then you need to use the protection.
Wow. And the printing process, how long did that take? And was it something that worked well with your family? I mean, working on this project while this device is printing and toxic stuff in the other room?
Well, yeah, I had to be mindful because in that same room, my parents do stuff. So I just had to ask them what if they were using the room, and if not, then I would use that time frame to work on it. But it was quite easy, although I did have to print a lot of pieces because some of them, like all the linkage pieces that are attached to the servo motors, these weren't designed like the other ones. These were like, I just made like a fast design, I printed it, and then I checked with the servo motor and everything. And then I would like change some measurements and things like that. So it was more like I had to print more of these pieces until I had like the perfect one.
That's great. Yeah, and a big time commitment to do that. So you're in your last year currently of high school?
Yeah.
And boy, I'm not sure how this works now with the pandemic for any students in the US that are watching this. In Europe, there's a program called Erasmus where college students can study in different parts of Europe. Are there any specific places in Europe that you think you'd like to study? Are there areas that have really exciting stuff going on related to the work that you're doing with this project?
Well, I know that there are great programs for biomedical engineering in Switzerland and Germany and the Netherlands. So I do plan to make an Erasmus to some of these places. And if not, maybe after I graduate university, go there to keep working on this.
Great. Yeah, there's some really exciting e-NABLE chapter developments going on right now in Germany and in some other places. e-NABLE France is a really huge chapter. I know there's some research going on in Germany related to animal prosthetics. Have you thought about the specific population you'd like to work with? I know one of the conversations that we've had in recent meetings is thinking about device development with specific input or feedback from device users and developing those projects together. But there's a big difference between prosthetics for children and adults, people that are born with a limb difference and people that have some sort of an accident and lose a limb and then have all these muscles that remember having a limb. Is there any specific group that you feel like you're interested in learning more about?
Right now, not really. Like I want to know a little bit about all these groups, but this hand I made it for amputees because, well, if you see the document where I have everything, the first part is actually, it talks about this, about how the muscles would need to be interconnected in order to make this hand move. So yeah, using, I don't remember how it's called.
Let's see. And again, this is 92 pages. It's really a well-organized achievement.
Thank you. It's
You let
this
me-
part.
This part. Okay, so page 8, section 1 on amputations.
Yeah, so this section 1 just talks about this agonist-antagonist interface that the user will need to have in order to make this hand move.
And did you also make this document in Spanish? And I ask this because we have a lot of community members in Mexico and South America. So if there is an alternative version of this in Spanish, I'm sure they would love to see it.
I did not. I made it all in English. But if they have any questions, they can ask me and I can answer in Spanish.
Perfect. That's great. Yeah, and really just a wonderful summary of you know, a lot of the factors in play, looking at the bone structure, looking at, you know, again, you spent a lot of time before this project looking at muscles and sort of the physiology involved, which is just really wonderful stuff.
Yeah, actually, for starting, I did not think there were many muscles that took action into the movements of the hand. It's actually very impressive.
It's a very impressive design, isn't it? The actual, the biological hand.
Yes, it is.
Hand. Yeah, it's quite a thing. And I
So,
know that
Jana,
Alexander, I was going to say, Alexander's been doing some research into some of this stuff as well. So you'll be able to talk with him on Friday. And he's been working on a device that's similar to yours, has sort of a push-pull activation of the fingers instead of using cables. So I'm sure he'll appreciate this document and have some much more pointed questions for you about your design and
Okay.
and that stuff. John?
This is such nice work that if you're willing to share not a PDF, in addition to a PDF, a Word version of this, people might well be able to do translations and other things.
Sure. Yeah, I can do it now, actually.
Well, that's great. Thank you. And Jana, what's next for you? I assume you're getting an A on this project.
Well, I hope so.
Are you done? Are you finished?
No, I'm not. So at the end of December, I had to, it was the due date for all this project that now you're seeing. So I gave that, but now in the middle of January, I'll have to make an oral presentation, but like the one I just did here, but I don't know exactly how they want it. So I'll have to do that and probably make the hand work also in front of the jury. And yeah, and then that's it.
Well, feel free to reference this video. Again, there'll be a link that I can share with you, and also the meeting on Friday.
And you can tell them that the co-founder of e-NABLE has seen a lot of these projects, had a lot of these presentations, and this is one of the most impressive.
I will do so. Let's see.
And I was just breezing through this document really quickly, but it's exhaustive. You've got a lot of good work in here, and I appreciate the organization of it.
Well, John, I hope you'll be able to participate in our discussions and work with Vivek and his group. And quite possibly, there are other e-NABLE volunteers who would like to work with your design. So I hope you'll become a part of our community. you didn't have to lurk at home all this time. It's great that we now know about you. I hope you'll stay involved.
Thanks. I want to. I send the link to the
Great.
doc,
Yep.
so people can add stuff.
Great.
And I'll add that to the event. It's really helpful. And so this document, is it open source, meaning that other people can use your work to do similar things and make changes in terms of different designs and that kind of stuff?
Yeah.
You understand open source and the notion that you might want to go to Creative Commons and actually choose a license.
Yeah, John, if you
add it to the document so people know.
Yeah, if you want to add a link, John, I'll go to the BMask website really quick, and I'll just copy that text to share for you, John.
Okay.
Okay.
But that's a really great point. John's been involved with patent development, but also open source stuff. And licenses are pretty interesting and important. So there's a hardware license. I'll just share with you this license page. This is a very different project. It's about masks. But this was the licenses that were used on, hardware license and documentation license for a different project. And it aligns with some sort of MIT open source software guidelines. But it's really wonderful to be able to share your work and also have attributions. So if anybody has an idea of how to improve it, they can work on it and then reference you and let you know what they're doing. And there can be some really great learning opportunities there for everybody.
Mm-hmm.
Jenna, you should know that we also, if you want to continue this work and you need money for materials or that kind of thing, I suspect that we could get you funding to continue this work. It's very impressive. It's going to be something the community can build on, and we have money in the bank. So think about how we can support you. It doesn't have to be with money. But
why don't you share a link, John, to Lumio
done.
and explain that a little bit?
I can. So here is a recent proposal to Lumio. So we have a system of authorizing funds for projects. Typically, it goes like this. Someone like you shows up who's done some really valuable work and has already impressed us, yes?
And let's zoom out to also think about high school students in general. So pretend I'm a high school student that's inspired by Jana's work. How can this Lumio process you're about to describe speak to me and my teachers in my school?
Well, very interesting. So if you were a high school student and not Jana, you might say, I want to learn how to do this, but I don't have a resin printer. But I'm a good programmer. And so conceivably, there would be a class and a teacher who would say, maybe you can help us get the print done, and then we can work on the programming, and we would support them. But
so e-NABLE supports
frankly,
open source.
It's easier for me to think through how Jana might be supported and to think about how incoming high school students would be supported. And for that, yes?
So Lumio is open for everybody. So Jana could create a proposal, or any high school could create a proposal. There's funding for equipment like printers. There's also potentially funding for open source lesson plans. So Jana, your documentation is really incredible. the work that you did, but it also could be a model, like John said, a learning sort of step off point for other schools. So, you know, thinking about activities related to the process that you went through that could be replicated by schools, where they can be doing something similar and learning. I think especially because of schools being, you know, you're in lockdown, as you mentioned. New York is also right now in a funny moment. So being able to have people working from home in different ways, like you've been doing, and collaborating with your teachers and potentially other students, that could be a funded project for Lumio as well.
Okay.
And just so those are all examples of projects that could be funded. The typical pathway to that is you show up, you learn about the community learns about you, you see something that the community would appreciate, you ask the community if this would be a good thing, the community says that would be a good thing, then you write a proposal, then we vote for it. So it's a gradual process, and Ben and I and others are happy to help you along the way. And of course, it's similar to the process you'll go through in graduate school if you become a biomedical engineer. But with e-NABLE, you can begin learning that right now, and you're ready for it. So you should feel free to think about how A, we can help you, or B, you might want to contribute to other students or non-students in the e-NABLE community.
So
Okay.
maybe as a next step, you mentioned there's places that have really exciting research going on in Europe that you are considering for Erasmus. You mentioned Switzerland, Germany, was it Sweden?
Netherlands.
Netherlands. I'm having trouble with the e-NABLE chapter map right now. It's not loading for me for whatever reason, but that would be a really great thing to check out in terms of what e-NABLE chapters are in those areas. And you might be able to, when you go to visit some of those places and connect to some of those schools, also connect to the chapters that are in the area and have their support on any of the projects that you're doing. That could be a really great way to network.
Yeah.
I'm afraid I have to go to another meeting, but Donna, I salute you. I look forward to seeing you in the community and on Friday. And congratulations, it's really, really beautiful work, well in advance of what can reasonably be expected of a high school student.
Thank you.
Yeah, really wonderful work, and please continue to join these meetings. So there's an education meeting once a month, and there's also the bionics meeting once a month, and you're more than welcome to join as often as you can.
Okay, I'll do so.
Great, thanks so much.
Thank you.
Take care.
You too. Bye.